All right, so we're approaching, I'll go over the exam today, exam 3. But I wanted to first announce, who needs this thing? Exam 3 right here, okay. The Computer Science Club is very active in helping new people coming into the early courses of computing, this class in particular. And they're holding what's called a study marathon on Friday in the lab areas. So all of the labs, there'll be these tutors available from the Computer Science Club, and it's an all-day affair. I think it starts at 8 a.m. and continues until 4 p.m. And I hear that they have pizza and drinks, which I think are free. I'm pretty sure those are free. So that's a good incentive. So come here on Friday and work with others who are also preparing for the exam, the final exam, which will be next week on Wednesday, in here at 12 o'clock. If you want more information about the Computer Science Club and this event, you can go here under Student Organizations, CSE Club website. These are the tutoring hours. There's no announcement here about the study marathon, but it is happening, in fact. Okay. All right. So here's the schedule. And the final lab is this problem of writing a tic-tac-toe program from scratch. Don't get one from the web, okay? That's easy to do. You search on tic-tac-toe and C++, get the code, copy it, paste it. No credit for that. You have to practice going through the thought process of building this application that plays tic-tac-toe. So resist the urge to search on the web for a solution and use that. You won't get any benefit out of that, no benefit. And you won't get any credit either. So if you copy from the web, then there's no credit for that submission. So you've got to work through this on your own. But let's go back to, before we talk perhaps more about this last assignment, let's go through this exam 3, make sure that everyone is clear about the solutions to these problems. So R identical, the first problem is to implement this function called R identical, which returns true or false, Boolean value, and returns true if A and B, the two vectors A and B, have the same size and exactly the same elements. So the element in position 0 in A equals the element in position 0 in B, and so on. So we have to check two things. First, we check to see if they have the same size, and then we check to see if each individual pair of elements between the two are the same. So let's just look at that quickly. So if A dot size equals B dot size, what do? Exam's over there. Let's find it in that file. Well, see, you should stop right here. This is where people get stuck on a lot of logical problems. If the sizes are the same, it means we can go on. So maybe it's easier to check to see if they're different. If the sizes are different, then we know for a fact that we know in this moment that they're not identical or return false right there. And let's go on with the code now under the assumption that A and B have the same number of elements. So we'll create a for loop that ranges through all of the indices of A, which happen to be all the valid indices in B as well, because they have the same size. Start at position 0, and continue while the index I is less than, exam paper is right there. Continue while the index I is less than the size of the vectors, because that'll be a valid index. As soon as it hits the size of vector A or B, then I represents a position that's outside the vector. So for each valid index I, we check to see that A of I, we check to see if A of I is not equal to B of I. And if that's the case, then we know right there that they're not identical. So after we complete the loop, if we don't return false inside the loop, it means every pair we looked at, A of I equals B of I. So we'll return true at that point. So we can return false at these intermediate points in the algorithm, but we have to wait until the very end until we return true. What about is lucky? I'll just close that off. Let's look at is lucky here. So what's a lucky vector V? Well, it's whatever we want to make it, pretend it to be, right? So what is it that makes this vector lucky on this exam? The vector should implement a function that determines if the vector only contains the numbers 7 and 8. The function returns true if each number in the vector is either 7 or 8. Otherwise, it returns false. The declaration of the function is shown in figure 2. So every number is either a 7 or an 8. Each number is either a 7 or an 8. It could be mixed 7s and 8s, or all 8s, or all 7s. So that means to see if V is lucky, we need to look at every value in V. So we're going to need this loop. I'm just going to save some time here and copy that. And this is an A, this is V. Whoops, what am I doing? All right, so what do we do when we look at, say, V of I? There's going to be some if condition, V of I. So this V of I has to be a 7 or an 8. So if it's a 7 or an 8, what can we conclude? Nothing. We can conclude that, well, maybe it's lucky, but we're not sure yet, because we got to look at all the other ones, all the other I's. So that's not a good test to look at. We want to see if the number is not a 7 and not an 8. If it's neither a 7 nor an 8, that means it's something like a 3 or a 5, right? Now we know we can return false here because we found one example, one number that was not a 7 or an 8. This is not a lucky vector. So after we go through that whole loop and we don't return false, then we can return true. That turned out to be the hard problem on the exam. So if that was hard for you, then you have to think about how to formulate these logical expressions that do what you want them to do. So what about number 3? Any question on this one? 1, 2? No. Write code that tests every statement in the isLucky function. Well, that means we need to write code that returns false and returns true. That'll run both possibilities. So we'll define a vector of int v. I'll show you minimal code, and some of you produced minimal code, and I was happy to see that. A minimal code, although it may not be a good test, it satisfies the requirement of the problem, and it's easy to grade because it's not a lot to look at. So let's push back. Push back 7. And then we assert that V is lucky. And now let's push back a 3. See, at this point here, V looks like this. And at this point, V looks like this. So V is no longer lucky because the second value is not a 7 nor an 8. Suppose we did it like this. Is that correct? A lot of you made this mistake. This was a common mistake. So once you get a 3 into the vector, it doesn't matter how many 7s or 8s you push onto it, you still have a bad number in there that makes the whole vector unlucky. All right, so that's a minimal test code. Of course, if you did more, then that's great. Really, it's fine. If you did more, it's good. So if you put on, say, an 8 here, this would be fine. This would be excellent. But minimal was sufficient for the problem. All right, what about max value? Find the maximum value in the vector v. Better make sure that's what it is. Return the largest int that's in the vector. So we need to look, once again, we have to look at everything in the vector. So we need a loop. We need to look at every value v of I. See, that's a good starting point right there, just to rough out. We know that that's some machinery that we need to have in place. We need a loop. We're going to look at v of I. I takes on every value that's valid for this vector v. Now we need to find the biggest value, so we're going to have to keep track of the biggest value. And if we find a new biggest value, then we're going to modify this variable biggest value. So we'll need to declare that variable biggest value. We need to initialize it to something. Some of you set it to 0, but that's not good enough. Setting biggest value to 0 is not good enough, because what if the vector is -9, -3, -11? The biggest value is -3. But you're going to end up returning 0 because you initialized the biggest value to 0. So the trick here is to set the biggest value to the first element in the vector, b of 0. And then return this biggest value. Any question on that one? The final, I would say that, the final exam has problems from all 3 exams. But most of the problems are similar to the problems in this exam 3. Okay? There's one smallish problem that resembles exam 2. And there's a couple of problems that resemble exam 1. All right, what about number 5? Our complement. Write a predicate function. Once again, it's a function that returns true or false, a Boolean value. That checks whether 2 vectors are complements in the sense that their elements pairwise add to 0. For example, the vectors -2, 3, 0, -7, and 2, -3, 0, 7 are complements because their elements pairwise add to 0. So the first pair, -2 and 2, add to 0. The second pair, 3 and -3, add to 0. 0 plus 0 is 0. -7 plus 7 is 0. So they pairwise add to 0. And so we would return true. They are complements. If the 2 vectors have different numbers of elements, then they're not comparable, so return false in that case. So that'll be the first thing we check. If A dot size is not equal to B dot size, then let's just return false. There's no sense in going into the loop. So now at this point in the code, if we haven't returned false, it means that A and B have the same size. So we can use A dot size, which happens to equal B dot size. And so we just have to look at the pairs. If we find one bad pair, then we return false. They're not complements. But if we look at all the pairs, we don't find a bad one, then we can return true. If A of I plus B of I is not equal to 0, then return false. After the loop is done, we return true because we've looked at every pair. We haven't found any that weren't adding to 0. What about count occurrences? Return the number of times K appears in A. Rows and columns are given. There's no need to declare those. So we'll need some loops there. We'll need a nested loop because it's a 2-dimensional array. And we'll let I range across the rows, and J will range across the columns. There it is. There's a nested loop. So now I and j will take on all the valid values in A, all the valid indices for A. So that lets us look at every value in A. So how do we look at a value in A? Well, it's just A, bracket, I, close bracket, open bracket, j, close bracket. That's how we access a value at position ij, row I, column j. How many times does k appear in that two-dimensional array? Well, each time we find a k, we have to increment a variable that we're going to use to count these occurrences. So let's declare a variable to do that. I'll call it occurrences. And so if we find a k, A of ij equals k, then let's increment occurrences. Right there. And it's 2 R's. I am such a bad speller here. There we go. So we set occurrences to 0, and then every time we hit it k, we get to an element that equals k, we increment occurrences. And finally, after the loops have finished, we'll return occurrences. There it is. And here's search. So find a value k in V, return its index in V. Do not assume the values are in order. Therefore, we cannot use binary search. And I'll just grab this loop up here. So many of these problems are just involve a for loop, 1 or 2 for loops. So let's look at every value in V. And if we find k, let's return the index where we found it at. And if we don't find it, we'll return -1. So if V of I is k, we will return I. That's the position we found k at. Otherwise, we return -1 as an indication that there is no index where k is at, because -1 is not a valid index. That's a convention. All right. And here's the final problem, which is to implement binary search. So in binary search, we have this range, and we keep shrinking the range, making it smaller and smaller. So we have a start index, which is at 0, and we have an end index. So the range is between S and E. And then we have a loop. We're going to continue having the size of this range until we either find k and return its position, or we don't find k. The range that we're looking at disappears because we toss every possibility out. That means we didn't find k, so we'll return -1. So the condition is that that S is less than or equal to E. While S is less than or equal to E, we're going to take a look at what's at S and E. If S equals E, let's look at that value that's at that location. If we find a K, we'll return S or E. They're the same thing. Otherwise, we'll exit the loop. We'll increment S or decrement E and then exit the loop. And when we exit the loop, we'll return -1. We didn't find it. So we're going to look at the midpoint of the range defined by the start and end indices, S and E. So the midpoint is the average of S and E. That's how you find a midpoint. Now, if V of M is K, we're done. We found it at M. Just return M, we're done. Else, if V of M, if V of M is greater than K, if V of M is greater than K, that means we want to bring the N down. I get this wrong sometimes. That means K is to the left of M. So we want to bring the end index down to the middle and -1 because we already checked M. Else S equals M plus 1. I think I got it. There we go. That's the hard part for me, is to get that one right there. All right. So that's binary search. What happens if this is if the numbers are in increasing sequence? This is what we use. What happens if the numbers were in decreasing sequence? What would we do here? Is that good enough? If the numbers were in decreasing sequence, that means if K were greater than the value at M, that means it must be to the left of M, because the big numbers start at the left. So that's it. One change if you want to do binary search on a decreasing sequence. All right, let's go back to the original. So that's it for this exam. Now there's this final lab that you need to do, and also the final exam, which is a week from this Wednesday. So we have the rest of today, and then we have Wednesday and Monday in lecture, which is a lot of extra time. And what I usually do is I go through this process of solving a problem that's similar to solving tic-tac-toe. So I can do that this year as well. I'll take another problem, which is called something 4 in a row, 5 in a row. What's that called? Cross 5. Huh? Anybody know what I'm talking about?
Is that Connect 4?
Huh?
Is it Connect 4?
Connect 4?
Yeah, that's the game.
Yeah, that's it. That's the one. I think that's what it is. It's called Connect 4.
Yeah.
Yeah, that's it. This is the one. So we can, try to get 4 in a row here, right? No, I lose. So the computer got 4 in a row. So this is what I did the last 1 or 2 times. I think I did this twice before I implemented this. So we can, it's a little bit more complicated than tic-tac-toe, but it's the same sort of approach. You can use the same solving problem methodology to tackle this that you would use to tackle tic-tac-toe. So, with the time that we have, we can finish it. We can't do it in one session. It takes at least 2 sessions. So that's that. That's this one here. And this is important. This is where, when you start working on a problem like this, then you're getting into software development. And it's not solving just a little algorithm problem anymore. Now you have to think more sort of widely, and you just have to think differently. You've got to tackle the problem. You're just at first, I would imagine you're really lost. What do you do? So that's the reason for this exam right at the end here. It's kind of open that door for you to walk through, to start solving problems of increasing complexity. And these problems are not necessarily complex in terms of the algorithm, the complexity of the algorithm, but just managing the whole thing. That the program has to do so many things. So how do you keep track of all of the factors that go into the program? How do you tackle a big problem? So so I want to start that. But before I do that, is there any questions about the final or this exam? Yeah.
Are you posting any practice problems for final?
Say it again.
Are you going to be posting any practice problems for final?
The practice problems are already everything is a practice problem, really. All the exam 1, 2, and 3, all those problems should be practice problems. All of these labs are practice problems. The practice problems I posted for exams 3, 2, and 1, those are, so it would just be more of the same. They're all very similar. So I'm not deviating very much from what you're experiencing doing the lab assignments and what you're doing to prepare for that you've already done to prepare for the exams. All right, let's get started. I want to just get the very beginning of this, and we're going to develop this thing incrementally, so it'll be step by step, and you can use the same process to write the tic-tac-toe program. Remember, don't look up code from tic-tac-toe. It's not going to do you any good. It's not going to help you develop the skill of programming. Of course, if you don't want to learn how to program, then don't bother to look it up anyway. Don't submit the lab. Just don't even work on it. But if you want to develop this skill, resist that urge to look up the code and try to solve it on your own using these iterative software development techniques that I've been showing you throughout the course. And I'll show you right now in implementing this Connect 4 game. So let's make a directory for this. And we'll do everything inside of a main. Oops. We're going to need a random number generator, so I'm going to leave the srand in there. Actually, there's a lot of good stuff in here. So it's we're going to do something like pick a column, right? So what the user does is the user, I'll do it like this. The user picks a column. And then we need to sort of put a marker in the slot that gets, the smallest available location in that column. That gets marked as the player's move. And then the computer, we'll have the computer make a random move. So you can do that in tic-tac-toe. Rather than having an intelligent computer opponent, you can have a dumb computer opponent that just makes random moves. Okay? That's good enough. So pick a column. And this is the picked column. Now, well, we'll do it like this. So there's going to be a loop that we keep picking a column. Maybe we'll have a Boolean variable, which is, we'll say done. Let's get rid of that. So we're going to have some kind of a loop here. And we're going to be picking columns in there. So, because we're going to continuously pick a column, right? So actually in this game, did you notice that? Oh, sometimes, the last time I played it, the computer went first. Now I'm going to go first. So for tic-tac-toe, you can do it either way. You can do a random decision about who goes first, but that's more complicated to code. Let's do it so to make it hard for the user, because the opponent is going to play randomly. So we'll have the computer does a move, and then the player does a move. Should be takes a move, right? That's the right verb. And when the player takes a move, we're going to have to ask the player to pick a column. We're just going to rough this out for now. Let's see if this runs. Control C, I have to kill it. We're not doing any input validation. So the computer's expecting a number. See, this line right here, this is where it's crashing. What's in cin? We're writing it into this picked column variable. But because this does a conversion, because the keyboard, that's character data. So the character data has to be transformed into an integer. But I typed in FFF. That doesn't represent an integer. So that means the input stream, cin, went into a fail state. And that means this command, when I executed this command in the loop, it just returned immediately. It didn't try to read anything from the standard input, because the standard input has already been marked as in a fail state, and we haven't cleared the fail state yet. So this is no longer a blocking operation. So normally it's a blocking operation. It waits for the user to enter something. It's blocking. I mean, the program is halted there. But now it doesn't block anymore, because standard input stream is in a fail state, so this operation simply returns without doing anything. So that's why we get that infinite loop. So it keeps printing pick a column over and over again. All right. Now, what do we do? Look at, after the computer makes a move, we have to check for a computer win or a tie, right? Every time, because this is a loop. This might be the last valid move. And after the player takes a move, we want to check for a player win or a tie. So after the player makes a move, it's either the player wins or it's a tie. And if it's a tie, then we're done. We'll print it's a tie, and then we'll exit. So that's when we'll break the loop, when it's a tie. Well, we'll break the loop if the computer wins or the player wins. So there we've got the sections of the code here. So the computer makes a move. And we'll do it like this. And then what we want to do is we want to display the board. Check for computer win or tie, announce the result if there is a win or a tie. Then prompt the player to make a move. And then display the board again, showing the player's move. And then check for a win or tie and announce the result if there is one. And we just keep doing that over and over again. So here we can display the board graphically. This is a graphical window. See, this is the browser runs inside of a window. And the program that's operating the window is can draw things. See, it's drawing circles and shading and colors. In the old days, this wasn't available. Monitors didn't have what's called a graphics mode. A monitor only knew how to render an ASCII character, like a digit or a Latin character, a character from the Latin alphabet, or some punctuation. That was it. It was like 200 characters you could display. And so it couldn't draw a dot, couldn't draw a line. This is the old days. It looked more like this. Here, in this window here, we're not drawing lines. This is a terminal window, so it only displays character data. And when we run in the terminal window, we can only render character data. We can't draw a line. We can't insert an image in the terminal window. It's not how the terminal works. So we've got two different kinds of programs. We've got these, graphical programs, which most programs are, or you have character-based programs, console programs. So like when you're in Visual Studio or Xcode, you're ready to create a new project, and you go, well, I want it to be a C++ project. And then there's this choice. Do you want it to be a console program or a graphics program? And then you pick one, right? So in this course, we're picking console program. So we're going to use the console program. So what we'll do is we'll sort of display the board every time a move is made. So the old boards will sort of scroll up, and we keep displaying the new board. So let's do it like this. Let's just make that a function. Get rid of the comment. I'm going to display the board. And displaying the board is going to be some kind of cout, right? So it'll look something like that. Pick a column, 3. Then we display the new state of the board. Pick a column, 2. Display, see, that's going to be the rhythm there. Control C, that's to kill it. We're in an infinite loop right now. So, well, what is the board going to be? Well, we'll have to figure that out. We have like this bottom row, and then the next row, and then we'll do it. Actually, we have to display the top row first, right? We're going to write the top row, and then go to the next line, write the next row, like that. So we need some way of representing this information in the program. So we'll use, we could use an array or vector. I guess we could use an array here. Maybe that's because the size of this thing is sort of given and known. All right, so we don't need to use vector. And it's let's see, 1, 2, 3, 4, 5, 6, 7 columns. 1, 2, 3, 4, 5, 6 rows. 7 columns. Actually, there's a two-dimensional array we can use there, right? Two-dimensional array. So let's suppose we have a variable for that. It'll be some data type. The board, which is, how many rows was it again? 6? 6 and 8? Did I do that? Or 7? 6 and 7. So what are we going to put in there? Well, we can put character data in there. That's what I like to do. We'll put in an X for the player and an O for the computer. It's like tic-tac-toe. Or a blank if the space is available. Or a dot, something like that. So we're going to put in characters, a char. We haven't worked with char yet. And this will work. This is what I recommend for the tic-tac-toe program, actually, to use a char. Maybe. Once again, tic-tac-toe is a lot easier than this. We're doing a harder problem here. So it's we have a board which is a two-dimensional array of character data. And let's initialize that. You know what? Let's make a function for that. So I'll do a knit board. I'll just call it just like that, just to get it out of main. I don't want it in main. I'll put it up here. And that's a void. So when we create this board, it's just random stuff inside of it. So should we use I and J or R and C? How about R and C for row and column? For row equals 0. So the row is less than 6. And then have a C. And C is less than 8.
7.
Oh, 7, thank you. Okay. So I don't know where I got 8 from. So let's put in, just so that we could either put a space in there, row, column. We could put a space in there. But we can't see the space, so maybe if we just put a dot in there, maybe, let's see how it works. We'll change it to a space if we need to. Just so we can see it's there. So a dot is an untaken space. Now notice I didn't use quotes here. I used apostrophes. So when you're working with string data, if it was a string variable, we would use quotes. But with character data, we use apostrophes. So this will not work. Double quote will not work. That will fail. You cannot assign a string to a character variable. So you use apostrophes to represent character data. Well, likewise, this is illegal. That's not I think it is anyway. This is looks like a string. It's only one. You can only represent one character this way. All right, let's see what happens here. Oh, we didn't call display board, right? Oh, We need to display the board now. So it compiles, but we're not displaying the board. Let's go ahead and display this board. So in the terminal window, we've got to print the first row, the second row, and so on, right? So this index, this is row 0, so R0. So this does what we want, actually. This does it right here. But at the end of the row, we need to have a new line. Whoops. So we need a new line after we print, all of the things that are in all the column positions within a given row. We need a new line. Control C. Oops, that's not going to work. It's it's too close together. So let's add a space in there just to space it out a little. Something like that. So when we take column 2, we're going to drop an X in column 2. Let's get that to work. Let's drop an X in column 2. How much time have we got? A few minutes here. Okay. You see how I'm doing this? I'm keeping main kind of simple. Like I could have put all the initialized board all right here. But wait a minute, that's going to make things messy. Let's just take care of it up here. Now I don't have to go back and look at this anymore. When this is done, it's packaged, it's done, we use it, get it out of the way. That's what a function does. Display board, it's done. It's packaged, it's encapsulated in a function, get it out of the way. We're going to use it. Well, we don't have to think about it anymore. We can just use it. And well, look, we're already using it twice. Well, we should be using it twice. And look, I'm going to get rid of my comment. See? I don't need that comment because the name of the function is descriptive enough of what we need to do there. So you see how I'm working on this iteratively? Well, this is how you do big programs. I mean, there's other ways of approaching it, by the way, but this is the way people do it in practice. I used to talk about, I'll figure everything out in advance. Don't do any coding. And nobody does it that way. It turns out that's an academic approach, and it doesn't work in real life. Almost all software development projects almost all of them are iterative. Because you got to know what you're building. That's the main thing. Is you can't just start coding. Here we have an example. You have to have a specification. This is what we're building. So you have to be very clear about what you're building, and then you iterate towards it. If the specification is fuzzy, then you're in trouble. Then you don't know where you're going. You're iterating, but you're weaving around. You don't have a target to hit. But now we know exactly what we're going to do here. Well, not exactly, but generally. So let's figure out this spot here. Player takes a move. Player takes a move. And let's do what we did already. Let's just tuck it into a function. We'll say player moves. Let's do that. I don't really like the name of that function. I'm going to do, I guess that's all right. Player moves. the computer takes a move, display the board, check for winner tie, player takes a move, display the board, check for player winner tie. That's it. Look at the main loop. Now look, it's looking pretty simple. That's it. That's the logic for the main loop. Now it's just a matter of writing a function that does those things and a little bit more. And we don't need this comment anymore, see? We know what's going on by reading the name of the function. All right, let's do this one. Pick a column. So we get a column. Now, here, I'm going to lose that one, right? Now, at this point, column 1, 2, 3, 4. Like this fourth column, see, not there, it's full. We need some kind of way to report an error message here. Like, we have to tell the user, sorry, that column, you can't pick that column. You got to pick a different column. So if the column is full, then tell the user to pick another column. Well, do it like this. If is column full, picked call, then, we tell the user that it's full. Something like that. Well, you know what? Then we have to display the board and everything. It's going to have to scroll up. So actually, let's not give any message at all, because I don't want to have to redraw the board. We'll just, if the column is full, then we'll stay in the loop. So if the column is not full, then we'll break from the loop. Yeah, I'm thinking about how to do this. So this would be so an infinite loop, and in order to break from the infinite loop, the user has to input a value into picked column that makes this function return false. Well, is column true? Let's make it easier. If it's an open column, you know what? I think it's even easier than that. What's an open column? If our board, I don't think we need a function for that. So we're looking at a column in which row? It would be row 0. If the picked column in row 0, is not a dot, well, if it is a dot, that means there's at least one space available at the top of the column. We don't have to check the whole column, right? Because they're going to stack up from the bottom going up. So we only need to look at the top. In our logic, we only need to look at, this space here in row 0. So if that column value in row 0 is a dot, which is our character that we initialize to, then we're good. We can break out of that input loop. So loop until the player selects a playable column. And when the user selects a playable column, then we have to put it there. How do we put it there? Let's write a function for that. Because actually, when the player moves, we can have another function for the computer to move. And so the logic will have to be shared across two functions. I'm just looking ahead. So 108. So we're almost there. Let's just finish this up, and we're done. So we need to put the character, we need to slide the thing down. So, if the user picks this column here, 0, 1, 2, 3, 4, 5, and I'm going to go 0 based for now. If we want to adjust it to 1 based, we'll do that later. So this is column, what is that? 5. So if the user selects column 5, then we need to, well, there's a number of ways of doing it, but I think the easiest way is to start on the bottom of column 5 and go into a for loop and increment the index, keep incrementing the index until the index hits a cell that has a dot in it. And that's where we're going to put the move. So we got a loop there. So let's do that. We can do it here, and then I'll move it into a function later. Let's do it because I know the computer moves will also make use of this logic. But let's move that logic later. Let's do it right now here. So I know I had to do a loop, right? So I'm just going to start with a loop. So for integer, now the row is going to vary, right? We're going up and down. The row is going to vary in the loop. And the column is going to be fixed. So we're going to use this variable r. For int r equals, we're not going to start at 0. We're going to start at the bottom here, which would be, what is that? 0, 1, 2, 3, 4, 5. That's the top index. So, and r has got to be bigger than or equal to 0. And then we're going to decrement r. So that's how we range. Now we're going to go backwards. We're starting at the end, 5. And we're going to go forward till we hit 0. So if, and I'm just going to use this right there. If board of R in the picked column is a dot, then that's our move. That's our move. If I find a dot there, because we're coming up from the bottom, we're going to put an X for the player. And then, of course, we're done the loop. Let's see if that works. Pick a column, 3. Look at that. Pick a column, 3. Oh, it's stacking up. Pick a column, 4. Look at that. Is that nice? There we go. Well, let's max out the column, what did I call it? 3? Yeah. All right, ready? I can do one more. And now when I do it, nothing. And I go 4. Oh, there we go. I get out of that. That's good enough for now. So you see, see how we're converging to the solution here, just step-by-step iteratively? We're going to finish this up on Wednesday easily, no problem. Then that means Monday is all just a day to review for the final. Okay, that's it for today.
So is it next week the finals week though?
Huh?
Is it next week finals week?
Yeah, but we have a lecture on Monday. Yeah. I mean, you don't have to come. if you're ready for the test.
So finals on Wednesday.
No new materials. Final is on Wednesday. Lecture is on Monday of finals week. If you haven't gotten your exam paper, come down to the front and take your paper.